All right, with this one, we learned this yesterday, solving linear equations here. Let's go through this. Now, I did give you a suggestion yesterday. If we're given this big juicy thing, let's take it and make it smaller piece by piece. So what I want you to do is to focus on the left here. Let's focus on the left and make that smaller, and then focus on the right and make that smaller if possible. And then we can start moving things from one side of the equation to the other. So on the left, what do I get? 2 is correct. So what's on next? We have negative 2x's plus 3x's. How many x's do we have? 1x. So I'm going to write plus x. Now there is a lot of people, and a lot of people did that in this hour and last hour. A lot of people, I was able to see on here, like a lot of people are still thinking that this is like 5x. We're having a hard time with adding and subtracting negative numbers, but it shouldn't be too bad. Guys, try to think of it like this. You don't just, everybody listen, you don't just float them together. You've got to say, well, we have negative 2x's, and then we're adding 3x's, so how many x's would we have? 1x, okay? So just be really careful as you do that. Okay, does that make sense? We're in debt $2. He owes me $2. Well, then he owes me $2, and then, oh my gosh, I can't put this in the real world. And then I give him, no wait, you owe me $2. This is hilarious. Okay, he owes me $2. Well, okay, then he gives me $3. How many dollars do I have? How many dollars are you good? That was a bad example. $1. Okay, bad example. Did you get that? Or did it just make it feel worse? Just made it worse. Great, Ms. Christensen. Thanks a lot. Okay, moving on. 2 plus x. Does everybody understand that part? Okay, is equal to -7. All right, so let's go through this and solve for x piece by piece. What do we do to get x alone?
-2.
Good, -2 from both sides. Now this is a positive 2, we're going to subtract 2 from both sides. Now look, if I add that up, it becomes 0, right? So that makes sense. So on the left, I have x is equal to, what's -7 minus 2 more?
-9.
-9. Very good. How many of you got it right? Raise your hand. How many of you were really close? You made a little error somewhere, but you're able to see now where you got it wrong. Okay, awesome. So you're not going to make that mistake again, right? That's why we're here, is to learn and make mistakes, okay? No, it's not all or nothing. It's not all or nothing. So you'll get most points. Yeah, most points. Pretty much if you did it pretty much right, you get pretty much all points. It won't affect you too much, okay? All right, moving on. Okay, so let's get out your stuff, ready to take notes, guys. We need to get started right away. Make sure you're ready to go. Today what we're learning is area and perimeter, and we're going to be dealing with area and perimeter of squares and rectangles today. And they work the same way. Area and perimeter for rectangles and squares work the same way. So first of all, I just want to talk about area. Area means like all of it shaded in, all the full amount. So looking at this right here, this rectangle, the area is the full amount shaded in here, all that stuff. Okay, and then perimeter. Perimeter just means sides. So to find the perimeter, we would add up all the sides, but perimeter just means sides, so the fences. The fences around the inside, okay? All right, so area is length times width. So everybody look at this rectangle right here. Notice I called this bottom part the length and then this smaller part the width. But really, in reality, if we wanted to be technical here, it's not going to matter if we switch these things for area and perimeter because length times width is the same thing as width times length. So really, if we switch those two on accident and called something wrong, we'd still be okay. Does everybody get that? Okay, so here's the formula or what we do to find area. So area is length times width. So we'll take the length and we'll multiply it to the width. And that will tell us exactly how much distance in there we're filling in. Now, I'm not going to write it all long like that every time. So I'm just going to show you what it's going to look like when I write it. Area is equal to, that's an L. Yes, my students argued all last year. That is not an L, that's a Y. That's a fancy L. That's what I'm going to write my L's. Length times width. So area is equal to length times width. That's why I'm going to write it shorthanded. And then with perimeter, you might see me write it like this. So perimeter is equal to side 1 plus side 2 plus side 3 plus side 4. We're just going to be adding up all the sides. There's 4 sides because we're dealing with rectangles and squares. Okay, any questions on that? Okay, let's get to it. Let's start out really basic here. Find the area and perimeter. So I'm going to ask you a question really quick. This one's very basic. Is this a rectangle or a square? Be ready to validate why you say one or the other. Is this a rectangle or square? Think about it on your own. Is this a rectangle or a square? Think about it on your own. Okay, now tell your neighbor. Is it a rectangle or square? Ready, go. Tell them why. Okay, beautiful. Group 3, I heard you say something awesome. Group 3, how did you know for sure? How did you know for sure that this was a rectangle, not a square? 3 and 2 are 3 is greater than 2. Those are not the same thing. If it was a square, would all the sides be the exact same?
Yes.
Yes. Okay, good. That was just a little side fun thing. Okay, so now we're learning lesson, guys. No talking. Area is equal to length times width. Let's find the area of this. So area is equal to length times width. So the area of this is equal to, what's our length? 3 times our width, which is
2.
So our area is equal to 6. Questions? All right, let's find our perimeter. I'm going to change colors here. Now, let's find our perimeter. So side 1 plus side 2 plus side 3 plus side 4. So how would you do this?
3 plus 3 plus 2.
Wait, 3 plus 3, where'd you get the other 3?
On the other side.
Oh, you're saying that this side 3 is 3, then this side's 3 for sure?
Yeah.
Okay, and then we have plus 2, and then you're saying since this side's 2,
That's right.
this side's 2, yeah, good, very good. Plus 2. Okay, so let's add that up. Our perimeter is equal to 3 plus 3 is 6, right? 7, 8, 9, 10. Okay, so now I'm going to have you think a little bit more advanced on a problem like this because you're going to see things sometimes written differently, so watch carefully. Could I have done the perimeter a little bit, not so, let's write it out so long. Could I have thought of perimeter like this? There's a point to this, guys, okay? How many 3's did we have? So could we have done 2 times 3 because multiplication, guys, is just repeated addition. So isn't 3 plus 3 the same thing as 3 times 2? Yeah, so we had 2 3's. That is true. We had 2 3's, and how many 2's do we have?
2.
So we could do plus, because we're adding up the sides, we had 2 2's. Let's see if we get the same answer. We better get 10, or we've done something wrong. 2 times 3 is 6 plus 2 times 2 is,
4.
what's 6 plus 4? 10. Does everybody see how the perimeter was found 2 different ways, but we got the same answer?
Yeah.
This is kind of the short way, really, right? I almost rather use that way. Does everybody see how, though, you can do it both ways? Okay, awesome. Let's do another one, a little bit more advanced. Looking at this one, it says, write a statement for area and perimeter. Write a statement for area and perimeter. Now notice, our rectangle here has a 2x and an x. So we're writing a statement. Are we going to be able to find the exact area and the exact perimeter? No, we have some variables in there, x, but we can still write a statement. So let's write a statement. So area is equal to length times width. So our area is equal to, what's the length? 2x, and then times by our width, which is x. Okay, now, wow, interesting. Let's simplify this. So our area is equal to 2x times x. Before you answer, we're going to be using properties of exponents, are we not? So we learned that for a reason. Yeah, awesome. Okay, yeah, we did. Okay, when you multiply the same base, what do you do with the exponent? You add them. So the exponent on x is 1. The exponent on x is 1. When you multiply the same base, you add the exponent. So what's our area?
2x squared.
Good, 2x squared. We added those exponents. Very good. Moving on to perimeter. Moving on to perimeter here. Let's do it the long way and the short way on this one really quick. Perimeter, let's add up all the sides. So we know this is 2x, this is also 2x. If this is x, this is also x. So our perimeter would be 2x plus 2x plus x plus x. So our perimeter is equal to what?
6x.
Now with this one, do we add, does the properties of exponents apply?
No.
No. Are we multiplying anything in here? No. So we're just combining like terms. 2x's plus 2x's is
4.
4x's plus 1x is
5.
plus 1x is 6x's. Wow, awesome. So we have a perimeter. Now I'm going to push us to think of it the other way for a reason. I'm not just doing this for the kicks and gigs. I'm doing it for a reason. So let's think of our perimeter the other way. we had how many 2x's?
2.
So really we have 2 times 2x because that's 2 2x's, and then we're going to add up how many x's? 2 x's. Let's see if we get the same answer here. What's 2 times 2x?
4x.
4x. And then we have plus, what's 2 times x?
2x.
2x. And now we can combine my terms and we get 6x. Awesome. You guys are awesome. Let's do one a little bit further. It goes a little bit deeper now. So this is just a statement, right? We couldn't find the actual area because we didn't know anything about anything. Good? Yeah. So our perimeter is just 6x. That's all. That's as far as we can go in this problem. Yeah. Good questions. Okay, let's do one that's a little bit deeper here. Pay attention. Pay attention. All right. So it says write a statement for area and perimeter, and then solve for x. Then it says given the perimeter is equal to 44. So solve for x given the perimeter is equal to 44. Now notice, I highlighted, well I capitalized the word perimeter for a reason, because that's super important. Now, some of you read that and are like, wow, that was a lot of words. I have no idea where to start. And guess what? You guys are going to be taking an ACT. You're going to be taking end of levels in this class, right? And a lot of times, guys, on the ACTs, and right, you'll all be taking the ACT. That's going to affect your immediate future. They'll have really wordy statements. The key is to pick it apart piece by piece and figure out what it's asking you to do. So I always just start out. I'm like, I read the whole thing. I'm like, wow, that was a lot. I'm not going to just say I can't do it. I'm going to go through and piece by piece go through it. So let's start out and just do the first thing with this. Write a statement for area and perimeter. Let's do that. Can we do that? Yeah. So let's write a statement for area and perimeter. So area is equal to length times width. Okay, so our area is equal to, what's our length? 10x, and then what's our width?
2.
So area is equal to what? What's 10x times 2? 20x. Good. Now I'm going to put a box around that just to keep my eyes there. Okay, let's move on to the next part. Let's write a statement for perimeter. So I'm going up here, and let's do it the short way. Perimeter. We know we need to add up all the sides. Now, if this is 10x, this is 10x. If this is 2, this is 2. So let's go through the perimeter and add it up, but let's use the quicker way. So how many 10x's do we have?
2.
So we have 2 times 10x. Now we're adding up the perimeter. So then plus what? How many 2's do we have?
2.
So 2, and we're talking 2's. Now if you wanted to do it the long way, I'm fine with that. Okay. All right, so our perimeter is equal to, what's 2 times 10x?
20.
So 20x, and then we have plus 4. Can we add 4 and 20x? No, they're not like terms, so this is where we would stop. There's our statement for perimeter. Okay, we've done the first part. Now let's move on and read the second part. Solve for x. Okay, well, we have x and x, but we can't just solve for x, so let's keep reading because we don't know anything. But it says, given the perimeter is equal to 44. So now we know the perimeter is equal to 44. So instead of a p, we know it, right? Do we know the perimeter is equal to 44? Okay, so we are given the perimeter is equal to 44. So if we know that's 44, let's put that in, and then we can piece by piece solve for x. So we have 44 is equal to 20x plus 4. Does everybody see how, since we were given the perimeter is 44, I just was able to put it in? Now can we solve for x piece by piece? So you're saying that when I taught you how to solve for a linear equation, which we did yesterday, it was for a reason? Yes?
Yes.
Yeah, awesome. Okay, let's solve for x piece by piece. How do I get x along?
-4.
Minus 4 from both sides. 44 minus 4 is 40. So we have 40 is equal to 20x. Okay, you're correct. Do you have any questions on those? Because there's some people looking at me with like a glare on their face, and I can't decide if it's because they don't know it or if they're just mad at me. So are you okay, everybody out there? Are we all okay? Okay, awesome. Moving on. Okay, because I don't want to move on if you're not getting it. Now what will we do? Divide by 20. Divide by 20. What's 40 divided by 20?
2.
So we have 2 is equal to x. So we just solve for x.
Yes.
And done. Any questions? Okay, try the next one by yourself. Try the next one by yourself. It says, write an equation for area and perimeter, okay, and solve for x. given that the area, I'm going to highlight that for you, area is equal to 64. Give her a try by yourself, and I'm going to have someone come up and do it. But
So area equals length times width. So you would do 4x times 2, which gives us 8x. And then you would tie that in. Since it says it's equal to 64, you would do, well, you do it that way. 64 is equal to 8x. And then you would divide that by 8x on both sides. And then we divide that by 3.
okay, stay up there. Awesome. You got the right answer. X is equal to 8. But I just want you to think, I'm going to ask you one question. Beautiful. But I'm going to ask you a question. We're trying to get X alone. So what should we divide by? Just 8 alone. So I want you to scribble out the X. Does that make sense? So we're trying to get X alone. I think you're actually going to go an extra X in there. Scribble out the X on the other side too, because we're only dividing by 8. Beautiful. So then we get X is equal to 8. How many of you got the same answer? Beautiful. Awesome. Now, interesting enough, I saw Justin over here, do something kind of cool. Thank you. That was beautiful. Very good explanation too. I like how she showed her work. It made sense, right? Okay. I saw Justin do something a little bit different, and his algebra was a little bit different, which was really cool. He got here. He said, okay, so 64, just watch, because this is really cool. I thought it was interesting just because we see different things here. 64 is equal to, and Justin wrote, okay, we have 4x times 2. Now, Justin, tell me, what did you do at this point? Okay, so you divided both sides by 2, and you got on the left, you got 32 is equal to, and then our 2's went away, so what was left?
4.
Interesting. Now, Justin, at this point, what did you do? Oh, you divided by 4. Okay, beautiful. And you got 8. 8 is equal to x. Good. Now, I did it like her. I did it this way. Justin did it this way. Both correct, different ways of getting there. Interesting. Good, good. Very good. Okay, guys. Now, this is the last thing I'm going to have us look at, and I'm going to set you free to work for quite a while, so stay with me. Everybody look at your worksheet. I'm going to do this one with you. Very top. Looking at this shape, it's interesting. Now, these look different than what we've been seeing. Now, notice, we have a bunch of boxes here. We have a bunch of boxes here. So with something like this, we can go through and find area and perimeter. Okay, so once again, area still means everything filled in. So let's pretend like I'm going to take this shape and fill it all in. We want to know how much that would be. So let's do it the preschool way first, and I'm going to have us think more advanced, and it's going to help us in the next thing. Let's think preschool style first. Let's count up how many squares this area takes up. 1, 2, 3, 4, 5, 6, 7, 8. Right? Area is equal to 8. Oh, yeah, that was easy. So when we have boxes, we could just count. But what if I blew this up and it was like huge? And we had 1,000 boxes. And we had 1,000 boxes. Would we want to count them?
No.
We wouldn't. Why in the heck did it do that? Hey, we wouldn't. So I'm going to encourage you to think a little bit more advanced. Now look what I'm doing. I need you watching. This will really help you, I promise, in later what we're doing in a minute. If I section this off and I just focus on this purple piece, what would my dimensions be on right here? This would be 3 and this would be 2. So if I wanted to find the area of the purple piece, that would be length times width. So what's our length? 3 times 2, which is 6. So the area of the purple piece is 6. Now we have this red piece and this red piece. Let's find the area of those individually. Well, what's the dimensions? 1 and 1. I'm doing this for a reason, guys, to help you. And then what's my dimensions on this one?
1.
So let's find the area of those pieces individually. Area is equal to length times width. What of this red box? What's the area?
1 times 1.
1 times 1, which is, and then what's the area of the other one? 1 times 1, which is, so now can I add up those individual areas?
Yeah.
1 plus 1 is 2 plus 6 is 8. Now some of you are thinking, that was a lot harder than just counting up the squares, and you're right, but we're thinking more advanced, and I'm trying to help you for later things. Okay, let's find the perimeter. Let's find the perimeter. I'm going to go through and I'm going to count. 1, 2, 3, 4, 4, 5. Are you following me? 6, 7, 8, 9, 10, 11, 12, and then how about 13, 14? Yeah?
Yes.
I just chose the dotted line. So our perimeter is 14. Okay? That's pretty neat. Okay, awesome. Okay, let's do another one. This one is one down on your thing. I'm going to have us think of the area in sections again. Now, your sections might be different than my sections, but I'm going to choose this to be a section. Now, I'm doing this for a reason, so everybody please watch. It will help you. So I'm going to choose these two sections. I kind of was off the lines on that one. So let's find, what are my dimensions on this purple piece up here? That's a 3, and that's a, and then this is a 3, and this is a, so let's find the area of those individually. Area is equal to length times width. So on this purple piece, what's my length? 3 times my width is, so we have 3, and then I have another piece like that, which is length times width, which is 3 times 1, which is 3. So I just found the area of the two purple pieces. I'm going to quickly find the area of this. What's my dimensions? 2 and a 1. So the area of the red piece, length times width, is 1 times 2, which is 2. So let's add those up. 3 plus 3 is 6, 7, 8. Now you could check it using the preschool way. 1, 2, 3, 4, 5, 6, 7, 8. And we got 8 squares. Okay, what's the perimeter? Now watch, I'm going to think of this. I'm going to think of this quicker. So that's 3, right? 3?
Yes.
4? 5? 6, 7? 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. My perimeter is 18. Okay, awesome. All right, work on the worksheet. Now, you can work on the worksheet. Now, I'm not going to go over anything else on that worksheet. You should know how to do all of it. You know how to do probability. We learned it last time. You should know how to graph a line. If you don't, though, did you just hear me? If you don't know how to graph a line and to go through an XY chart, I'm going to do a video at the end of this video when you guys leave. I'm going to finish off and do some examples for that. So let's say you didn't know how to do problem number 1-38 on the worksheet. If you watch the end of this video, I will have help. Okay, so you have help, and then I'm available before and after school. But you should know how to do that because you learned it last year. But I will have a video on that part. It's just going to be at the end of today's video. Okay, work for a while, and then we'll do our activity, our fun competition in just a little bit. I know it's hard to pull yourself away from the worksheet, but I'm going to have to ask you to put them away now. I'm sorry. Put them away. Okay, we're going to have a really fun competition, and it's going to be in your teams, okay? So, chocolate and Starburst are on the line, and then major bragging rights. I'm sure you'll all brag you won the snack competition, okay? So what we're going to take what we've learned today and apply it in a real-world context, and we're going to have to think creatively as a group and really think critically. So everybody listen to the directions, please. On your desk is a paper. You're going to find in the paper somewhere there's like a rug. There's a little piece you can pull out. So inside there, look inside. It might be in the front or back. Pull out the rug, but leave the paper inside. Yep, it's just like that little square. Does everybody find it? Okay, now read the problem and you're going to do it. So you all need your notebooks because you're going to be needing to do some work. Now only one person in the group has to draw it out. So there only has to be one person draw it, but you'll all need your binders out working. Like you'll need to be able to take note, or like you need a paper and pencil. There we go. Okay, so once you've finished all of it, then I can come check, and the first group to get it 100% correct wins. Now, you have 2 hints as a group. So you have to decide as a group if you want to cash in on a hint. Ready, set, go. And you all need to be working on it. Okay, so people struggling with linear equations, I promised an example on one that looks like the problem. Let's see, it was 1-38 on the worksheet of 1.2.2 for area and perimeter. So looking at this, we have to remember back to secondary math 1, how to graph a line. So the first thing I always start with is, and really the first thing we should all start with, is graphing the y-intercept, meaning where it crosses the y-axis right here on a line. That's the y-intercept. I'm going to abbreviate that. So I'm going to go down starting at the origin. Origin means the very middle of the graph here. I'm going to go down -5 because it's -5. So -5, that's where it's crossing the y-axis. Okay? Now, because this is y, this is our y, this is our x-axis. Okay, so now we want to graph our slope. And we can use our slope if we were given it to finish off this line. So notice our slope is 3/4 because remember lines have the form y is equal to mx plus b. M is our slope. So our slope is positive 3/4. Now remember with slope, slope is rise over the run. Rise over run. So we're going to be going rising 3 and then running 4. So from the y-intercept, you always start at the y-intercept. I'm going to go rise 3 and then run 4. So I'm going to go up 1. I'll erase this in a second. 1, 2, 3, just so you can see what I'm doing. And then over 1, 2, 3, and 4. There's my, I guess I'll leave those there. There's one of my points. Now we could keep going. We could do that again. From there, you'll go up 1, 2, and 3. And then over 1, 2, 3, and 4. Okay, so now that would be part of my line. Now you can do it again, but it's going to go off up here, off to the right. It's going to go off of our graph. So then also we can keep drawing this line. We're going to go down 3 and over 4 backwards, just because remember, really guys, this is a straight line. So if I wanted to draw this straight line, it's obviously going to be continuing down in that direction. I'm just showing you with my arrow because you can't see me pointing. It's going to continue down that way. So if we want to continue drawing our line, we could also go down 1, 2, 3, and then over this way, 1, 2, 3, and 4. So now I can draw my line in. Now I didn't connect those dots perfectly. It's hard on the smart board. I should have tried to do it a little bit better because it does need to cross through those points there. That's a little bit better. Okay. Okay. So now, if we wanted to find, if we wanted to go through and it says plot, let's say it says make an XY chart, what we can do, guys, is we can actually just, and I'm going to erase this really quick for a second just so I can have a fresh look at this. We could go in and plug in values for X and Y. So let's say we didn't even know how to graph a line. We could still be able to graph this line because we could plug in values for X and then we would get our Y point. So I always like to start by plugging in -2, -1, 0, 1, and 2. So then you could go through and plug in those values into your equation and see what you get. So I'm going to plug that in. So I have 3 times -2 over 4 minus 5. I'm plugging in -2 into the equation so I can get what my Y is. So if we plug that in, we're going to get -6 over 4 minus 5. And we'll do it on a calculator really quick. We could do it by hand. It's going to take a second. Just make sure when you do it on the calculator, you use parentheses around -6/4, so your calculator knows it's a fraction. Okay, so -6.5. When we calculate that, you should get -6.5. So when I put in -2, I got -6.5. All right, I'm going to erase that and then plug in a -1. Okay, so let's plug in -1 now. So let's see what our Y is when we plug in -1. So I have 3 times X, which X is -1. We're plugging it in over 4 and then minus 5. So we could calculate this. We would get -3/4 minus 5. Once again, I'm going to type it into my calculator using parentheses. -3 divided by 4. I could bring up my calculator and show you, but I'm just trying to kind of help you quickly here. And then minus 5, so -5.75. So these aren't that pretty of values, but that's okay. Let's plug in 0 now and see what we get. Okay, plugging in 0. So we have 3 times 0 over 4 minus 5. Well, 3 times 0 is 0. 0 divided by 4 and then minus 5. Okay, so 0 divided by 4 is 0, guys. And then minus 5, so we get -5. So when at 0, when we plugged it in, we got -5. Okay, awesome. Now we can keep going. We can plug in some more values, but I'm just going to stop because really this is what we are looking for here. Now, looking at this, It wants to know, okay, where is the, oh, let's see. Okay. I'm trying to see what problem 38, sorry about that. I'm trying to see what problem 38 was asking me for. Okay, so it wants to know the actual, it wants to, okay, so we could plot these values, guys. Just keep in mind here looking at this. We could just go over, so look, if we plotted these points, we would have 0, -5. So right here, we're going over 0 and down 1, 2, 3, 4, and 5. We've already, right there, I didn't mean to erase that. Right there is our point at 0 and -5, right there. So then we had our line. Now we could have kept plotting these points. We could have gone -2, -6.5. So we could have gone back to -2 and down to 6.5 and put a point there, down -6.5. And we could have kept doing this, and we would have eventually, when we plug in all these values, we would have figured out what our line looks like. Now if it asks for the x-intercept, that means where it's crossing the x-axis. So mine kind of looks like, I didn't draw a perfect line, but it's crossing the x-axis somewhere around here. So if I just tried to eyeball it, we would think it was 6, but it might not be 6. It might be something like 6.111. It might not be crossing exactly at 6. So I strongly suggest you doing the algebra. Okay, so this is how you'll do it. So to find the x-intercept, it's kind of interesting, but you'll plug in a 0 for y. Okay, so now because, think about y here. If we want to know the x-intercept, we want to know where that green point is. Yeah? Now our y, if we were crossing the x-axis, is 0. We didn't go anywhere on the y-axis, it would be 0. So if we plug in a 0 for y, so we have 0 is equal to 3/4 x minus 5, then we could go through and solve for x piece by piece algebraically to find out what x is. So I'm going to go ahead and do this one. So solving for x piece by piece. So it feels odd because you're like, I'm finding the x-intercept. Why did I plug in a 0 for y? But you really do, and I kind of explained why over just a second ago. So now piece by piece, I'm going to solve for x. So I'm going to add 5 to both sides. So then I have 5 is equal to 3/4 x. 3/4 x. Now we're trying to get x alone piece by piece. There's a couple different ways we can do this. What I want you to realize is this is the same thing as 5 is equal to 3x over 4. Same thing, okay? Because when you multiply fractions, you multiply straight across. So then from here, solving for x piece by piece. X is being divided by 4. There's a couple different ways you can do this. But x is being divided by 4. So I'm going to multiply both sides by 4. So then over here, our 4's divide out, and on the left, I have 4 times 5, which is 20. 20 is equal to 3x because our 4 is divided out. And then from here, I'll divide both sides by 3. So I'll do that. Now that's not going to come out perfectly. So then our x is by itself. So 20 divided by 3. That's 6.66666. So I'm going to change it back to a fraction. So it's 6.666, and then it goes on repeating. So it's crossing at 6.6. So does everybody see how if I just tried to eyeball it, once again, looking at my green point, it looked like it crossed at 6, but it actually crossed at 6.6, more like right there. But we couldn't really have seen that without doing the algebra. So if you're asked to find the x-intercept, plug in a 0 for y, and then solve for x piece by piece. So I guess this answer is acceptable, I guess, for something like this. But I think your answer is going to come out prettier than that. I just kind of threw this example together quickly. Okay, so just make sure that you do something like that. Okay. All right, now I think we should be good. All right.